Can you hear me? Hello, is anyone there? Hello, can you hear me? Is anyone there? Can you hear me? Okay. Muhammad, yeah, you're welcome. Good, you can hear me. So just share. Let us see how we can get a few people to join us. Okay, I can see. Let's just see how we can get a few people to join us, and then we start our session. So thanks for coming. Okay, so let's just give some time for others to join. Then we start. Is it okay? Okay. Okay. So can you hear me? Okay. Okay. Let's just wait for others to join. Just a few minutes, then we start, please. Okay. So everybody can hear me, right? Just type the chat. You can get me. And please share so that others can join us and benefit from this session. Okay, yes. You're welcome, Ahmed. You're welcome. Okay. Okay. So let's just say we start in let me look at the time here. Let's just say we can start in 2 minutes. So that would be 10:40 from my side. So we can start in 2 minutes. So who has Sagemaker Studio Lab already? Does anybody have it? Sagemaker Studio Lab. Let me open it up. Does anybody have this Sagemaker Studio Lab? Okay, nobody has Sagemaker Studio Lab already. Okay, so we will starting in let's say under 1 minute. Okay, so but then you can still use your, if you want to follow along, you can still use your Google Colab, Google Colab, Google Colab to follow along. Or if you have Anaconda in your machine, you can still use it. Or you can use, let's just use, so you can go to Google Colab to follow along here. And then you also have you can still do your try Jupyter here to follow along, depending on you. But we are going to use the IPython notebook in this our hands-on. So whatever you feel comfortable with, you use it. So you can go to your try Jupyter and use it, or your Google Colab to follow along. So you see here, you can still do your import with your Google, import your whatever here. So either you use Google Colab or you use your try Jupyter, but all it will still work. So but I'll be using the Sagemaker Studio Lab. So okay, I think we can start. So briefly, I'll just show you briefly. So in reality, we are, it's this Sagemaker Saturdays is a series that we'll be having every Saturday like this, with the objective of building end-to-end machine learning projects. And part one means that we'll be, because we'll mostly be using AWS SageMaker, which is a #1 cloud. So part one would be using inbuilt models in AWS. Then we will move on to part two, which would be using custom models like TensorFlow. And then part three will be bringing your own Docker container and your own models to the system. So today we are doing part one, day one, which is scraping data. And then we'll continue to build a model and go on with a project, a complete project with that, because you have to collect the data, you have to clean it, do feature engineering, do your modeling, and then deployment. So let me just open the folder so you see. So if you see here, I have a repository here, and there is a project here. So if I open the scraper, I'll share this link with you. So if I open the scraper already, we are trying to build a land price prediction app using AWS SageMaker's inbuilt XGBoost. You know, XGBoost has helped win a lot of competitions. So in reality, we always start with the problem statement. What is the problem? So why are we doing this? So many people in Cameroon, when they want to get lands, they need to get the price of meter square to buy land. They need to call many people, call to get the price per meter square. So there's no system. So we're trying to build an app where we visit this site, which is I opened it here. Let me just go back because I already opened it here. So we visit this page. We are going to scrape this page, which is where they are posting. It's a classified ads website where they are posting prices for land. So you see this land here, location is at Odza. Then they are selling, the price is 35,000 francs CFA. So that is the price per meter square, and then they are selling 3,013 meter square. So this is what we are trying to scrape. So our objective today is to go here, collect location, collect the price, collect the meter square, so that we can build a machine learning model in subsequent editions, which can be able to, you put in the location and the meter square, it gives you the price for that area. So you don't need to be calling people again on phone. Oh, what's the price of meter square in Oza? Oh, I forgot. I wanted to ask also what's the other price of meter square in maybe Bonamusadi in Bonanjo. So in reality, these are towns in Cameroon, if you're from Cameroon. So there's some bit of domain knowledge because it's my country. So I'm able to understand some of these prices of land, and which will also help us be able to do the cleaning later on to see there are some errors in this price of land. So today we are going to scrape this to be able to get this data. So I have as I open here the repository, the project, the file here, you see we have the problem. That's the problem we are trying to solve. We create an app that somebody just puts in the land, the neighborhood and the meter square, and then it predicts the price per land. So the first level, we are going to scrape the data. So we are going to scrape it from this classify web ads, which is what we are going to do today. Then next week, we are going to go to perform exploratory data analysis, which is being able to look at what is in the data. Then we are going to do feature engineering and selection, and then we build, train, and deploy our model in Sagemaker, AWS. So this is it. So if you see, this is the code at the repository. We have already done this, but we are going to do it together today from scratch because we've already scraped this data. And at the end, we are hoping to have a data set, a CSV file, which will give us this as the objective, which will give us the price, this one, location, Oza, meter square, this. So this is what we want to do today. So let's move on then, and let's start our exercise. So I'm going to go to my Sagemaker Studio Lab here. I already have an account. You can request for an account if you don't have an account. I'm going to sign in. So I'm signing in. So when you sign in here, you have the possible. What I like about it is that you have these free GPUs. I can either use the GPU or I can either use the CPU. But for now, we are going to use the CPU. When we'll be doing maybe deep learning projects, we'll need to use the GPUs to hasten up things. So I'm going to start a runtime. So you, as I say, you can still use your Google Colab. Go to Google Colab. Google Colab. You can use Google Colab to follow along. And if you have any questions, you leave it in the chat. So you can use Google Colab, or you can use Try Jupyter here, Jupyter Online. So you can do that, or if you have an Anaconda. So now let's start. So here we started. So I'm going to open now a project. So I'm opening a project, and now you would see I'll come into the Jupyter Lab. It's very familiar if you've used Jupyter Labs before. So now I'm going to create a new, let us create our new Python file. Default is Python. You select there. So now we are in the same page like somebody who went to Google Colab or through your Anaconda or through your Jupyter Lab. So now the first thing we are going to do here is we are going to first thing we are going to, because we'll just give a title here, so we'll do web scraping, land price data. Okay, so now when you run that, so what do we do? These are the things we'll do. The first thing is that we need to import our libraries. Import libraries. Next thing, we need to create create our functions, which will do our ETL for us. Create our ETL functions. And then when we have those ETL functions, now we need to scrape the data. And then now we now create a CSV file of the data. So this is what we are going to do today, create a CSV file. So this is what we are going to do today. So I'll just go to Markdown and then enter. So now, first thing, let us import the libraries. So here we are going to go like that. You know, that's just to put the comment. So import libraries. So we are going to be using, I'm changing this to Markdown. So I could just press M, change it to Markdown, then I press Shift Enter. So now we are going to be using these libraries, import import requests, and then we are going to from BS4 import beautiful soup. So these are the two libraries that we use. If request goes and gets the URL from this website, you'll get this, or get this, you'll get this. And then now what we are going to get there from the, let me go back here. Yeah. So what we are going to get here is from beautiful soup. Now we are able to get into the HTML file, and then we can extract all the things that we want. Like, for example, we want the price, we want the location. So let's just go ahead. So if somebody is coding along with me and you have any questions or any comments, please leave it here. I'm watching and I'm here to respond. So let us see how you have any questions. I can help you out. So I'll just press Shift Enter. Now we have imported our libraries. So the next thing now is that we are going to start creating our ETL functions. Creating ETL functions. So now let me just change this to Markdown. I can either press M here, or I go up here and I select it as Markdown. Then I create it like a smaller title. So that's it, creating ETL functions. So this could be number 2. So let us move on then. Now, the first thing is that when the request library helps you get this. So normally, if we go back here, I'll type the land plots, Jumia land plots. So when we type that, okay, now we get these lands. You see, this is 1, this is 2, this is 3, this is 4. So our first, and these are pages. So our first objective is to create a function which gets the page, so that we can be able to say scrape page 1 and all this, because if we open each of them, it goes to one listing. If I open, say, the first one, it gives me Odza. I'll collect this. So I open the second one, it gives me this other Dual. I'll collect this. So what we are actually trying to do is first create a function which gets this page first, and then the second thing now is to go inside each of these and get them one by one. So let us go back here. So we copy this URL, copy, then we come here, we say we come back here, we say okay, response. Now want to see if we can access that URL. Response equals to request dot get. Now we put in the URL here. So we want to see if we can get a response. Then to check, I'll just type response here so that we see if we get a 200. It means we are able to access the file. So you see, we get this 200. It means that we have access. You get something like 400, 500, all those are errors. Now it shows that we are able to access this website. Now to see the content there, we need something, we need beautiful soup to be able to get us the HTML from there. So that's where we need to say, okay, now let us call this object soup equals to beautiful soup. Then we get that response dot text. So we get the text file from that this first response, and then now we tell it that it is an HTML. So we give this condition HTML.parser, pass it as HTML. So when we close that, and then if I put soup here, for example, so that we see what it looks like, I press Shift Enter, we run this. So we see we have access to that website. So we can check. We see things like sell your plot, website property, sell land in Cameroon. So which means that, okay, good, we have access to this site. So I'll just go and then remove this so that we don't have too many too many things there. Clear output. So we've seen that yes, we have access. So next thing now is that, okay, after the soup object, we need to go now and find out here, how can we click this part? So how do we click this? Our problem is that how can we make the object to click this? So now that's when you go to your inspector, you click on your inspector. So you try to look at the tag here. Say, okay, I want to be able to click this thing here, to click it like this, and then let it open ODZA. That's what we want the thing to do, so that we can be able to have that list. So we go and then we say, okay, how can we identify each of these? The good thing is to try to go up where, watch here as I'm going up. If I click here, article, if I go to next article, I'm on the second, go to third article. So if I'm able to loop through these articles, I'll be able to get them. So I can check here. I go to Control F. I check here article. Then I'm able to see that, okay, when I go there, I have article here, article here, article here, article here, and each of them is each of these. So if I can grab this article, then I can be able to loop through to get the data that I want. So that's why I'm going to go back here, and then I'm going to say, let's say list URLs also equal to, now I'll go to soup dot find me where you see article, and then I want all that is article. So since there are many, that's why we have to use find all, because there are many. So let's run this. So if I just run this for us to see what it looks like inside, we click here and run it. You will see that you have different articles. The Odza 35,000. Let's move down. The Douala 12,000. The Peka 21 5,000. So you're seeing that you have the different articles. So if I loop through, I can just get each of them. So that looks okay. So now I want to be able to get just the URL, like we clicked here, like we saw here. Let me go here. I want to get just this URL here. And I realize that this is partial, so which means that it first needs to have http.jumia.cm before it continues like this en/terrain. So I need to be able to add the http plus jumia.cm to this one before I'm able to open it here. So when I go back here now, I'll say okay. So which means that for URL, or it's a partial URL yet because it's not yet full. For partial URL in this list, so I'm going to take up this one. First of all, let's take out this output so that it's not confusing us. Edit, clear output. So for partial URL in this list URLs, for loop, in that list URL, so let's just say print partial URL. So we see. So when I run it, okay, I have not dot find article. So I have not selected yet my, okay, let me go back here. So okay, so let's go back there. Okay, so now, which means that what we are trying to get is to get the href here. So, and we have to get the A class. Let me go back here. Let me go back here. Let me show you. So we have that. Now, if I come here and I go to inspect, we are trying to get this partial URL here. So which means that it is in an A class called this post link, and then we are able to get the href here. So if we are able to say go to every article, take the A class, and then get us this href, we should be able to get this partial URL. So let's go there and let me show you. So let me go back there. So we are going to say for partial URL in list underscore URLs. Now, so let's say now that you see that print partial URL dot find now your A, then you want to get the href. So let's run that. So what do we get now? You see, we get the partial URLs. So this is what we are looking for. So our objective will be to take the base URL, which is HTTP, this base, and add it to that partial URL. So which is why we are going to say, for example, print. I can now declare a base URL here. Say base URL equal to this. And remember, this one comes already with a slash. So I don't need this slash here. So I need to take off this slash so that it will be https.jumia.com/ this odds. Next one, https. So what I need to do is I need to say now add concatenate these two. So take base URL RL plus partial URL. So when you run that, what do you get? You get now this. So if you click on this now, for example, you see it is opening now each of the individual pages here. So we can, next level will be to get our prices. So that's good. So now let us create a function with this. This one went off. Let's just put it back here. So let's create a function with this. So I'll go back up here. Now I'll start creating my function. So put a line there, trying to show you so you see the procedure, how we go about it. So now I'm going to say def extract pages, get page URLs. So I'm creating a function, and then I'll need to give it the page number. So which page number, so that I can say maybe from page 1 to page 10, give me the data. So get page URLs. The first thing we want to do is to get our response. So we put it here. So there's one more thing. This is not complete, the URL. I need to see the page here. I need to see something like page 1 so that I can say if page is 1, it should change. If page is 2, it should change. If page is 3, it should change. So how do we do that? That is where we go back here. We say, okay, these are the pages. When I click here, notice something. When I click on 2, it starts giving me the full URL. So the full URL is http:// page 2. So if I put page 1, it's page 1. You give me page 1 with the odds are. If I put, say, page 10, it will take me to the 10th page here. So you see, I can be able to loop through when I get this. So this will be my URL. So I'm going to copy this. Now I'll take it back there. Let's put it back here. I'll take it back there. So which means that instead here now, we'll change this URL to this one, to this. Then instead of the page now, we use an F string. Then we use the F string to create, to say each time you see page here. Oh, sorry, I'm supposed to do it up here instead. I'm supposed to do it up here in the function. So let's do it here. F string. So each time you see page, then so if I put page 1 here, it should go to www.jumia page equals to 1 and scrape it. So if I put page 10 here, it should get that. So that is the function, that is the how we're going to get the response. Then the next thing we're going to pick from here is the soup object. So the soup object is going to be this beautiful soup, this response here dot text HTML parser. Then we are going to get our base URL. Let's declare it up here. This is our base URL. Then now we are going to get this from here, which is for this line here. Let's put it here. So if you put it here, put this like that, you know we have to do this indent. So we are saying for partial URL in URL list, so we can now just give it a complete, so we can say new URL equals to base URL plus that. Now the thing is that this is a loop, so we need to store it somewhere, like in a list. So we are going to create a list here, an empty list. So we are going to say maybe URL list equals to that, an empty list, so that what we can do now is that we can append to this list all the time. So URL list dot append this new URL. So I'm going to print it and then you'll see. So this new URL. So now if I run this function, you know, not okay, so what do we say? We say base that on match. Okay, so I haven't closed the bracket somewhere, so is this bracket here. Okay, so let me run it. Now if I call this function down here, I'm going to call that function get page URLs, and then we are going to give it a page number. I'll just call it on page 1, and then we get page URL page 1. So when we call that function, it's getting the page URL. So let's see, we have an error, URL list not defined. I haven't defined this, so I have to run this first, run this, then I run this, and then I run this. So now when we do that, now we get that. So our new object now, which is the URL list, should contain those URLs. So if I come here and I add this and then I check URL list, URL list, you see I have this. So I have this list now. So we've successfully created this function, and we can say for page in page 1 to 10, give us this list. The URL list is going to keep adding. You have a very long list, even 100 of these URLs in that. So fine. So we have our first function, which is to get the links to the pages. So now our next thing now is, okay, when we are inside a page, how do we get now price? How do we get now area? How do we get the location? Good. So one problem has been solved. That's good. So now let us move on then now. So let us limit ourselves to maybe URL list 1, just the first element, so that we can use it to get our new function. So we just take this one as the input of the next function. Okay. So now let's move on then. Now the next thing is this one now says, okay, let us do our new response request equals to get now. Let's call this URL. Let us give it an object URL. So which means that we can now say get us now this new URL, which is that first URL we saw of Odza. Get us this new URL. Then now give us the response. So now it is now trying to access this new URL now, so that we can start getting the 35,000 from it. So let us go back here now. We go to get the new URL. So we run it. We check our response. Yes, 200. It means that we have access. Then we create its own soup object too and see it, its own soup object. So we create its own beautiful soup object, soup, for that first page, first URL. So now we see that we are inside the Odza. If we go somewhere, we'll see the 35,000 somewhere. So we are in the page, which is good. So now let us clear this. Go back to edit, clear output. Then now we now try to say, okay, how can we get now the first element, which is say the let's go to start with price. So let's go there and see, for example, or let's start with location. No problem. Let's say, okay, Odza. Let's inspect. Now for that we say, okay, where is Odza found? Odza is found in a span with item prop equals to address locality. Let's check if this address locality is everywhere. Control C, Control F, Control V. We see that it's just one of one, so it's the only address locality. So if we are able to find this address locality in this span with this item prop equals to address locality, then we are able to get to this where we can go and get Odza as the text inside this span. So that's why you need to understand a bit of HTML in scraping. So let's go now and do just that. So I'm going to go back here. I'm going to say, okay, so if I want to get area, yes, location equal to soup dot find. Now we said you should find the span. We should find this span which has item prop equals to address locality. So let me address locality. Let me copy it. Copy it so that we have exactly that. Copy. So we go back here. We say soup.find span. Then we create a dictionary. That's how beautiful soup works. You need to create a dictionary and say item prop is which value. You give it this value that we just copied, address locality. So now we are telling it that go and get that location. So let me just put print location here and let's run it. So you see we have that whole line span item prop address locality equals to Odza. But this doesn't interest us. What we want is the Odza only. So that's why we are going to go and add dot get text, get underscore text. So when we go to get underscore text and run it, you see we have now our Odza. So this is already one of the things that we've already found out. So what can we do already? We can start now creating our second function and be storing our things there. So we say our second function is def. Let's just say extract transform. Then you give it a URL. And in that URL now, the first thing is that it's going to go and get this response from the URL, then create a beautiful soup object. We can just copy these two at once because you create a beautiful soup object and give us the location. So we will create the beautiful soup object and the location. So already we have location. Now let's go and see how we can get area. Let's go and try to get for area. Now we already got for location. So for area, we go back here. We have to inspect. We go to meta square. We go to area here. Right click. We go to inspect. So we see that area is here, and then there is this H3 here. So let us check how many H3s we have. So because we need to look for something that can bring us closer to the area. So we see here there are 34 H3s. This is the first. Then let's go to the second. We see that the second H3 is in area is inside the second H3. So if we can be able to index, find all H3 and just select the second, we should be able to get area. So let's just do that. Let's go back here. Go back here. We say, okay, area equals to soup.find. Now we said we should look for the H3. Okay, now what do we need? We need to find all the H3 because when you use soup.find, you get just the first H3. So you need to say soup.find all. And then you remember indexing. Now we index and we say we want the second element. Remember Python is a zero index. So if you put 0, you're going to get the first element. If you put 1, you're going to get the second element. So we say area equals to soup.find H3 and give us the second. So let's just run this and then let me put area so you see what it looks like. We are sure that are we the right. So you see we get our area, we get the 3013 meters square, which is what we are looking for. So good, we are in the right position. So now let us do dot get text as we did before. Dot get underscore text. We run it, so we get this. So but now this doesn't look good. We need to clean it, so which means that we need to be able to remove this area here and then remove this meta square so that we are just left with this. So the first thing now is that we do dot replace. So if you run that, that's what you get. So now that's what you get. So now let's move on. If we do now dot replace, this other one now, we need to replace it. Dot replace that with this, nothing. So if we run it, we get now our 3013, which is good. So now we can now copy this, take this up. Let's go ahead. So to get price, inspect. Now we are sure that okay, we can get price from here. So our price here is we look at price currency. So if I copy this and I paste it here, price currency, so we have that. Now it means that if I'm able to get this span item prop equals to price currency, then I'll be successful to get the price, which is here. Sorry, if I'm able to get this price here, up here, if I'm able to get this price, this span item prop price, then I'll get this one here. So let's go and do that. It's almost like the first one. You get the span price, you get the span and then price item prop. So let's go back there. Think having a problem with my connection. So let's go back there. Let us go to what we did here in the location. So we can say soup price equals to soup.find. Now we said span. Then we say item prop. Item prop. We put our dictionary again. Now we said is equal to price. So item prop equals to price. So we got price. Now we close our dictionary and then we close it. So if I run price, what do we get? We get the prices. So but we get all of this. So we have to do dot get underscore text to get that. But we don't want this comma here. So we need to do it. We say dot replace the comma with nothing. I'll just put this so that you see it. So close it, run it. So we get the 35,000. So fine, we have our elements here already. So we have the soup, we have the location, we have the area, we have the price. So that's good. Now the next thing now is that we are going to create a dictionary with items equal to this area is area, price is price. So we created a dictionary. Let's close it. So which means that the next thing we want to do now is to, when we do this, we want to store it in an empty list, just like we did for the first one. So we can go up here and create an empty list, which is, let's just say, items list. Items list equals to that. So here we are going to say items list dot append items, and then now we run this. So let's run this. So if you remember, if we run this and then we initiate our URL to be this one. Now let's run this one, and then we check now this item list that we created. Let's check the item list down here. Let's check item list. I need to first initiate it, run this one, then I run this one so that we can get back our URL, so that we can get this first. Let me go back here. Okay, so I think we have the function, which is first function, second function. Now the next thing now is just to try them. Let's try them and see. So we are going to go with the get page function first. Get page, let's run it. So when we do get page, we see if we can get a URL list. We got it. Now let us go now and then we do the other function, this one, run this one, run this function. Yeah, so we get, then now we pass on because here we got our URL list. Here we got our URL list up here. When we did it, we got our URL list. We got that. So we are now going to take this our URL list element and run it here to see. So we want to run the first URL list here. The first one, just run the first one. 0. We index it. So we want to run it here. Extract transform. Then we check our items list also. So you see, we already have location, odza, area. We already have something in our items list. So let's check why we are getting that. So let's check here. So our first thing is that we need to initiate our items list from up here. Then we run our code. So let's initiate it, run this one. Let's run our code. Then we see what we get. So we get first the list, and then now when we come and run this one now, we get our location. So which means that now we are able to scrape our page because we have the first step, which is to scrape the page. So here, scraping page. So enter. Now we are going to say for page in range 1 to 2, let's just scrape a single page. Remember, I've already scraped some data already in the former project, so I'm just redoing it. So let's just scrape one page. So for page in range 1 to 2, now you let us call now this function, this get URLs page. So let's call it. So if we say for page in range 1 to 2 get URLs page, we should be able to get a good URL list. Correct. So that's good. Now we can say now for URL in URL list, which is what we have up there now. So now run now this second function, which is this extract transform. So extract all these and transform them. So come here, copy it, run it here. So which says for URL in URL list, extract transform URL. So we should be able to see now our items list. So it's running. It's running. So it's taking much time. I think I'm having problem with the connection. Let me stop and okay, good. Here is good. Okay, good. So you see we have them now. Location Odza, area that, location Douala, area that, price that. So we have them. We have our list. We have our list already. So if I go through this, let me run so let me clean now the code and let's have an entire run. So I'm going to take off this one so that we have an entire run where we're trying to create the functions and then be able to run it then. So let me close this one, close this. Now let us run it now. So which means in summary, we are importing libraries, we are creating empty lists to contain the list of URLs, the list of items at the end. So let us run this function, second function, then actually scrape the pages. So we say for page in this range, run that, and then for URL in URL list, run that one. So it is scraping now. So you see these are the two lines to scrape the page because we already have built our two functions. So now it is fine. So we have Odza, area is Odza, this is the meta square, the location is Odza, the price is 35,000, this is the location Douala, price is that. So now we have our clean function. So the last thing to do now is to convert to CSV. So this was the third. Then now the last thing now to do is to convert to CSV. So foot, convert to CSV. And then now what will happen here is that you will need now to bring in pandas because you need pandas to be able to do that. So you say import pandas as PD. You import pandas as PD. Then now you will say now that data equals to PD dot data frame. Then now you give it now this list, this items list here. So it is now the items list here. Then now when you run that now, call data, when you run that now, you see we have our data frame. So it's good, so we've been successful. We have our data frame, location, area, price. That's good. So now the thing now that we need now to do now is just to save it now to a CSV file, and then we can be able to continue in the next stages. So we'll just say data dot to underscore CSV. Now we give it the name of the file that we want to save it. I'll just call it land price data. Then you say .csv. Now if I'm going to add this condition, we say index equals to false. Why am I adding this? Because if I don't, okay, let me run it. Let's run it. So if I run this, see, land price has been created here. So if we click here to open it up, so my problem is this thing now. I have this index and I have this other index. So that's why I have to go and I add the line index equals to 4 so that it should take away this line. So let's go back there. Then I'll add it there. So I'll just go and then I'll say, comma, index equals to false. Run it. Then we check again. Let me close this first one. Then we run it. Then we check again. So you see the index is gone. So now that we only have now location, area, price. So we are good to go. So the only thing I could do now is that when I come here, I could add the pages, maybe say from 1 to 10 pages. Please be gentle with the website. So I could say from 1 to 10 or from 1 to 5. Then I run this. So let's just add maybe one more page and run it and let's see. So I'll just go back up here. We'll just run everything. We'll go through and we'll scrape 3 pages. So again, in summary, to scrape the website, we had to import these libraries, which is the requests. Then we had to import Beautiful Soup. Request gets you the URL. Beautiful Soups gets you all the HTML tags. Then we create this empty list, which we are going to append our things inside. The first list is to get the list of all these websites. The list of all these 1, 2, 3 per page. So we are trying to get per page. That was the first list we created. Then the second list now was to get the list of to go inside the individual items now and get the data. So this first function, def page, this is the base URL. We access the page number 1 or page number 2 or page number 3. Then we use Beautiful Soup to create the HTML object. Then now we use now the soup.find to look for where we got article, the article tag. When we saw article, we realized that with article we are able to get all the 9 per page, 9 items that are sold per page. Then now we get the partial URL and add to this http://jumia.com / each of the individual products URL, so that we are able to create now the list of URLs per page. So if there are 8 objects per page, this function gives us those 8 objects per page. Then now we take each of those objects, now their links, their links, URLs, then we pass them in this extract function. So we say go to each of those URLs that we have up there, create another Beautiful Soup object, which is their HTML inside, then go and look for location to get the land, the area, or whatever area. This is where it's found. This is what we use HTML to get. Go and get the area. This is where the area is found in H3. Get the text, remove the area part, remove the meta square part, just give us the figure. So we could still even convert it to integer at once. Say, okay, we want an integer. We don't want it to be text. Let's convert this to integer. Price to, go to this span, get me this price here, get the text, and then replace all the comma between the 3 digits. So we could also say all this should be an integer. This should be an integer. And then now we create now a dictionary, which is made up of the title, which will be our column headers. Location is this location. Area is this area. Price is this price. Then now we append it now to that list. We add it now to this our empty list that we created up here, which is this list up here. So when we did that now, we could now scrape the page because we have modularized our code. We just have 2 functions to run and change whatever we want to change. If today we want page 1 to 100, it will be here. If we want page 1 to 2, it will be here. And then we just use a for loop on the second function to loop through all the lists that this one has created to get this file down here. So at the end of the day now, we convert it now to CSV using pandas and we store here. So let's just run it one more time. Run all. So we're going to run all. Let me just close this file. So now we are on 1 to 3. Let's run all. and then at the end we are expecting now to get an updated land price CSV here, which you see is let me just open it here. If we open it up here, this is what we get. So it is 2 pages because it is longer, 8 per page, so 16 items. So I hope this has been able to give you an introduction to how you can scrape. There's more to it. There's more to it. So this is the data we'll be using for the subsequent editions. So if you have any comments, if not, I think it is good. We just need to get this data now into the next stage, which is the feature engineering, and then we start cleaning our data. So are there any questions, any remarks, any points? If not, then we've come to the end of our program of today. Okay, so thank you all, bye bye. See you next week. Bye bye.